What up, everybody? Today we're talking about impulse and change momentum, and we're looking at an example where Bubba Head drives into a brick wall. Okay, and that's going to have an impulse because the wall is going to put a force on him, and it's going to have a change of momentum, and those two are going to be equal to each other. So, impulse is what the wall does to him. It's the force it's the force that the wall pushes on him, multiplied by the time that the wall is doing that to him. Change of momentum is the effect on him, right? How his momentum changes um, as a result of running into the wall. And it can be seen by the equation that you see on your screen here: force multiplied by change in time equals mass times change in velocity. Where the left side is the impulse, and the right side is the change momentum. But when you put them together, you get an equation with four variables, which means that if we have three of those variables, we can always solve for the fourth. So let's look at three different examples. All right. First, each time he's going to be going 40 meters per second, and each time he's going to come into a complete stop. The mass of him and his car put together is 500 kilograms. All right. So we have some numbers to put into these equations. Let's see what the effect is of these different barriers that he's running into. All right. So the thing that changes if you run into something different is the time of collision. So if he runs into a brick wall, he's going to come to a stop really fast. If he runs into a bale of hay, it's going to take him longer from the time he first touches the hay to the time that he comes to a stop. So the time of collision is longer. If he runs into like a mountain of marshmallows, then it's going to take him even longer to come to a complete stop. So what effect is this going to have on the collision? Let's see. Okay, so first of all, let's watch him run into the wall. And we'll start with the equation. We don't know the force, but we do know the time, the mass, and the change in velocity. His velocity went from 40 down to 0, and that's why we say the delta V is negative 40. All right, so we'll multiply the two numbers on the side there and divide by the number on the left so that we can get solve for F. And we put that in a calculator and find the answer, we get negative 2 million newtons. Okay, negative comes from the fact that it's just pushing him to the left in this case. Right, so the force is a negative 200 newtons, which means him and his car are going to experience 2 million newtons of force, which is, if you can imagine, would be a very serious accident. Now, he's going to run into the bale of hay instead. Okay, same mass, same change in velocity because he's still going from 40 meters per second down to 0. But when we put the numbers in, we're going to see something different. So the right side of the equation is still the same as when you ran into the bricks. Okay, that hasn't changed. But the left side, the delta t, is larger, so when you divide it, you're going to get a smaller number. It's not going to be 2 million, it's going to be negative 40,000. Okay, so still a lot of force, but quite a bit less than what he and his car would experience running into a brick wall. So you see that the time of collision increasing caused the force to decrease. All right, so just make sure we see this pattern correctly. Let's let's have him crash into a mountain of marshmallows. He comes to a much slower stop this time. Okay, same equation. See, the right side of the equation is the same because that's his change in momentum. His change in momentum was the same each time he's run into something. The thing that he runs into doesn't change that because he's going at one speed and then he comes to a stop. So his change in momentum is identical for these three collisions. But this time we have a larger time, so we divide by that larger time, and we get a smaller number. We get minus 6,667. All right, so increasing the time of collision can significantly decrease the amount of force that he feels. So running to the brick wall was 2 million newtons, which could be easily a fatal accident. Whereas running into the marshmallows is much more safe, 6,000 newtons of force that he would experience. Okay, so the moral of the story is if you increase the time of collision, you will decrease the force felt by the object colliding. Right, and that's the reason for airbags, for bumpers, right, for padded mats in sports. Uh, those things are meant to slow down the time of collision and make the time of collision last longer and not be so sudden, so that the force that the people involved feel is much smaller. Okay, I'll see you on the next video.